winning at maths GCSE higher. Alright then, I'm going to do like the quickest whirlwind of GCSE in a series of videos, and we're going to start off with like numbers, essentially just numbers, and this video is going to be all about integers. So we're doing GCSE, and we're going to do integers, and this is what we're going to do. Right, this is our order of operation. We have integers, that's this video. We're going to start off with, actually, I'm going to move operations to the front. But first we'll talk about what is an integer, then we'll talk about the operations that we do on integers, types of integers, what highest common factor and the lowest common multiple is, then an inverse, and then down here, order. The order of things that we do to integers. That's big maths. So I'm going to get this on there, then we're going to go straight in with what is an integer. Hope that would look like a magic trick. I don't think it has. Anyway, right, so what is an integer? Mathematics all starts on numbers. It's essentially just problem solving with numbers, and the most basic of numbers are the ones which you can count with. I have 1 finger, I have 2 fingers, I have 3 fingers, 4, 5 fingers. These are countable things. If I take 2 fingers off, chop them off, then we're down to 3 fingers. That's an operation that I just did. I don't mean surgical, I mean as in minus numbers. So, this is what an integer is. Integers are whole numbers. So we've got like things like 1, 2, 3, 4. It goes on and on forever. But we're also going to throw in 0 into the mix, and also the negative numbers. Also, negative. I've written a little minus sign in a VE because that's shorthand for writing negative. If you want to write positive, guess what? It's a plus sign and a VE. Positive. That doesn't make sense. So these are what integers are. All of those. Now I'm sure you're familiar with things that we can do to numbers. You've got your plus, you've got your minus, you've got your multiply and then divide. Now in mathematics we've got loads of names for those. We've got product, difference, add, subtract, plus, minus, all these things. They all mean the same things, and it's based upon those 4 operations. They're called operations because you do it to numbers. So let me just write those down, then we'll define them. Right, this is what we're playing with. Sum, difference, product and quotient. These are just mathematical words to mean sum. That's adding. The sum of 2 and 3 is 5. 3. The difference, that's just minusing. So the difference between 3 and 2 is 1. Product, that's multiplying. The product of 2 and 3 equals 6. Now the quotient is divide. Looks like I'm listing Ed Sheeran albums, but I'm not. Divide, this is a very GCSE symbol for divide. I usually write like a slash because I mainly teach A level and up above that. But we'll just do this for now. I'm going to choose different numbers. 4 over 2 is 2. If I did 3 divided by 2, that would have been just 3 over 2. You can't split that into whole numbers. And the reason for that is based upon its factors. So factors is the next thing that we're going to look at. And I'm just going to move this because we put this at the top. All right. So, factors, 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 factors. A number can be split up into its factors. What that means is that you kind of chop it up into things that divide by it, and you get an integer at the end. So if we did 3 divided by 2, you can't get an integer at the end, but sometimes you can. So, just got an email. Let me write this. Factors are numbers that divide another. So, can you see that down there? It's quite small. Yeah, it's fine, it's fine. The best way to find the factors are where you do this tree, a factor tree. So we're going to do 24. We can write 24 as being like 12 times 2. So I've done that. 2 has no factors other than 1 and 2, but we don't count that one. But 12, we can split that up. We could say 6 and 2, or we could say 3 and 4. Doesn't really matter. 3 we're going to stop there because that can't divide. 4 could be 2 and 2. And what you've got left with is the prime factors. These are very important. They're important because the prime factors are like the end point of any number. So every single number can be written as a multiple of its prime factors. This one would be 2 times 2 times 2 times 3. So 2 times 2 times 2 is 2 to the power of 3, because there are 3 lots of them, and then times 3. So we could write it in index format. And there you go. That is prime factors. Isn't that nice? Now prime is a certain type of integer. It's one where it hasn't actually got any factors other than itself and 1. Now, that means that 1 technically is not a prime. And it's not. We'll never call it a prime. But let's talk about types. This, where is it? Here. These are our types that we need to know about GCSE. We've got even numbers. That's just things which have a factor of 2 and you get a whole number. So, you know, like 2, 4, 6, 10. Anything like that. So 2, 4, 6. What about 0? Is 0 a prime? It is. What? Why do I keep saying prime? Is 0 an even? It is. So we throw that in there as well, because 10 is 1 as well. Incidentally, what we can do is we can then write any even number is 2 times any other number, where that n is just any integer. What that means then is that an odd number, which is 1 different, odd numbers can't be divided by 2. So like 3, 7, 9, 1. What about minus numbers? Well, yeah, they are odd numbers too. Minus 1 is an odd number. You can't share it by 2. So we can write these as 2n plus 1, because it's just 1 different from an even number. That makes sense, doesn't it? How about square numbers? So square. You take a number, you square it. Right, so square 1, well, that's 1. Square 2, 4. Square 3, 9. And those numbers that you can't come up with after that, they're the square numbers. 3, 9, and so on. They're all the square numbers. Now we could write that in a similar format, just n to the power of 2, which means the cube numbers are just n cubed. These are ones like 1 again, but now it's 2 cubed, which is 8. 3 cubed is 27. Oh, come on. 4 cubed is 64. 5 cubed is 225. No, it's not. It's 125. And then, yeah. Now we've got our prime numbers. So prime numbers are ones which can't be expressed as other factors. So it hasn't got any factors. So 1 isn't actually a prime. So we're going to start at 2. 2 is the first prime. Then we've got 3. Then we've got 5, 7, 11, 13, and it goes on and on. It's actually meant to be an infinite number, but no one has ever figured out an equation that predicts primes. That is a mathematical medal if you figure that out. So that's primes. As I said earlier, you can express things as a product of its prime factors. Bada bing, bada boom, that is it. Now, let's move on to the next one. Okay, we're moving on to this. HCF is highest common factor. That's an initialism, highest common factor. What it means is that if you are given 2 numbers, say it's 24 and 9, we want to know what the highest factor that they both share. That's why it's common. How do you do that then? Right, well, let's look at this. So we know that 24 can be written as, and 9, if we did our tree, is just 3 times 3. So the highest common factor, the factor that they both share, and the highest one, is 3. Now that was really easy, so let's do a harder one. What we're going to do is 72 and 120. So first we've got to figure out what the prime factors of 72 are. Let's do our tree again. 36 and 2. So that's the prime factors of 72. No, it's like, it doesn't really matter what way you do this. If I went down a different route and instead of doing 72 is 2 and 36, it would still get the same answer. I'll show you with 120. That's quite an impressively long one. But I could have done it a different way. Right, so let's just write this down. I'm going to do it again, but instead of 60 and 2, I'm going to do 30 and 40. 4. Ends up with the exact same ones. So same as before, we're just going to select the highest common factors. It's not 2, it's not 3. Oh wait, it is 3 because this one I've got 5. Now we're going to do lowest common multiple. This one's a bit more tricky. So this is initialism again. LCM, lowest common multiple, is my microphone. Yeah. Same thing, right? But what we want here is the lowest number that both of them will divide. Let's just go straight in. What we're going to do is we're going to use these from before, but you use it to make a new number. So what you do is you choose all the factors which are shared between the two. 2, 2, 2, 3, 3, but then the one that isn't. So it's 5. So you choose your lowest one, do all of those, and then the factor which isn't in them both. And that should get you the answer. So 72 times 5 is 360. And to check, 360 divided by 120 equals 3. That's the lowest common multiple. Now these are quite tricky to work out because I think this method of choosing all the factors and all that lot doesn't always work. But just use your noggin, figure out what is the lowest common multiple. So like if you had, say, 12 and 10, let's just say 12 and 10. Now we've got a starting point, and that's where you just times them both together. That's one common multiple. Then what you're going to do is you're just going to chop that up until you get it down to the smallest one, which both has them in. So it's 60. That's it. Really? Yeah. Okay, inverses. This is getting near the end now. So imagine that we're going to do one of our operations: add, subtract, divide, or multiply. What's the inverse? What's the opposite of those? If I've got a number, say it's 5, and I add 3 to it, that equals 8. What's the opposite of adding 3? Well, obviously it's minusing 3. So inverses is like the opposite thing which undoes it. So inverse of plus 3, the inverse is minus 3. If you times by 3, the inverse is divide by 3. But obviously that goes both ways. The good thing about this is that this is used in rearranging formula. If we had something like an unknown, a variable with some integer and we don't know what it is, let's say it's, do it in purple. X plus 60 equals 144. I chose 60 because that's from before. Just a random number that I had in my head. Chose 144 because it's a square number. It's actually 12 squared. My camera's flashing. I think it's fine. So what's the inverse of adding 60? Well, it's taking 60 away, subtracting 60. So if we take 60 from both sides, it's going to get rid of that, and it goes over there. So x is 144 minus 60. So x is just 84. That's how you solve an equation. We're getting there. Got such chalky hands. Right, we're on to our last one. Order. Order! It's a little bit like what they say in House of Commons, you know, the speaker is like, order! Or if you're in a takeaway. Order. But what does it mean here? See, all of this maths that we do is all built upon some rules. I hope that wasn't getting on my speakerphone, the microphone. It's all built upon some rules. Some people sat down a long time ago and they were like, right, what rules have we got to do mathematics with? And they made them up. And everything that we do is built upon these rules. And the rules make new rules, and then they're all backing each other up. And that's what makes it so exciting, that you can make rules to make new rules, and those rules are actually really useful. So, order. Order. If I wrote down an equation, 6 plus 4 divided by 10 minus 3 plus 16 times by 4. What is it? What order do you do this in? If you did 6 plus 4, that's 10. Then if you divide it by 10, that's 1. Then if you subtract 3, that's minus 2. Add 16, that's 13 times by 4, that's 52. But what if you did it slightly differently? What if you said, right, 6 plus 4 divided by 10? Well, 4 divided by 10 is 4/10. That's not an integer. Okay, that's odd. What if we did dividing it by 10 minus 3? So we're dividing it by 9. So 6 plus 4 is 10 divided by 9. Oh, no, that's not. Oh, man, it's all messing up. What if it was 16 times 4? So then it was 64. So we're adding 64 to it. That's completely different. So we need an order of how we do things, and it's an acronym. These are all initialisms. Now we're at an acronym, which is meaning that we're actually going to say it as a word, BIDMAS. But it stands for something. This is what it stands for. I hope you can read that. Is it even on the screen? I think it is. Brackets, indices, divide, multiply, add, subtract. Now it's really hard writing that way down. It might be really hard reading that way down. But what it means is that we need brackets in there to say what we're doing in what order. So we might do that. Okay. But then it says you do your indices after your brackets. We haven't got any indices in here. That's like if we had a little square like that. Let's say there was a square. Then you do your divides, then you do your multiplies, then add, and then you subtract. So that means that we'd have to do those brackets first, then we'd have to do that indices, then we'd do our divide, then we'd do our multiply, so it would be 16 times by 4, then you add and you subtract. But because this is in your bracket, that actually means that you do that one first. Now this is the rule. That's the rule. You have to just remember that. And that's useful in doing things like this, but where they're really complicated. Especially when you get to like A level and you're rearranging actual formula, like the cosine rule. So that was the integers. Now what comes next is the numbers which are in between integers, and that's like the ones where we had, if we're going to do 3 divided by 2, it's not a whole number, it's not an integer. So that is the next step, which is looking at fractions. Some people struggle with these. They really shouldn't actually. They're kind of basic, like one number on top, one number on bottom. This one's your numerator and this one's your, we'll talk about it next time.